Dear participants, welcome to this session and to the third International Congress on Human-Computer Interaction, Optimization and Robotic Applications. My name is Emir Köksal. I have been working as Associate Professor Doctor for the Department of Mathematics of 19 Mayıs University, Samsun, Turkey. Now we have 7 presentations in this session. The duration of each presentation is 10 minutes. Now, the first speaker is Christoph Gand, and the title of the talk is Design and Implementation of a Photovoltaic System for Self-Sufficient Energy Supply of Mobile Robots. Christoph?
Hello, could you hear me?
Yes.
Okay. Hello, my name is Christoph Geng, and I would like to invite you to the presentation of the design and implementation of a photovoltaic system for self-sufficient energy supply of mobile robots. Let me give you a short overview of the content of the presentation. First, I would like to give you a brief description of our rover Ares. After that, we will look at the design and positioning of the solar collector. Then I will describe the design and function of the collector tracking system and the charging circuit. Finally, I will give you a short conclusion and show the sources used for this presentation. In this picture, we see our Mars rover Ares, developed by the Frankfurt Robotics Science Team, short FROST. It is a belt-driven mobile robot with a 5-axis articulated arm developed for the European Rover Challenge. This is an international competition in Kielce, Poland, where student-developed rovers have to complete various tasks in a Mars-like environment. In this project, we equipped the rover with a self-sufficient power supply using a solar system that tracks the sun and is mounted in the rear of the rover. This allows our rover to operate independently of the local power grid. Here I have summarized the most important facts about the dimensioning. The rover requires an average electric power of about 444 watt for operation. At the Kielce event site, the average irradiation is 533 watt per square meter, and the module efficiency used for the design is 21%. With these values, the required horizontal area for a continuous power supply of about 4 square meters can be calculated. By implementing a 2-axis collector tracking system, the electric power generated can be increased by 44%. This reduced the required area for a continuous power supply to 2.8 square meters. As a comparison, the footprint of the rover is only 0.6 square meters, which is about 22% of the required tracking area, or 15% of the required horizontally orientated area. For this reason, we have decided on a cyclical charging process with charging breaks of up to 2 days. Here we see the rover Ares with 5 different possible collector positions. Position 1, horizontally on the rover, is unpreferred because the articulate arm interrupts the collector surface and shades it permanently. Position 2, above the rover, in green, is less optimal because this position shifts the center of gravity of the rover upwards and has a negative influence on the driving behavior. Position 4, to the side on the rover, is unfavorable because a very strong mounting is needed to move the long and narrow collector. There is also a high risk of damaging the collector during rotation. Position 5, in the front of the rover, is less optimal because the collector can easily be damaged when moving straight ahead. For this reason, we choose position 3 in the rear of the rover. In case of obstacles behind the rover can be turned and damage can be avoided. This position also offers the possibility to use the collector weight as a counterweight for the front heavy articulated arm during operations. In this picture, we see the rover with 5 different collector sizes, and in the table on the right side, we see the different types with the power, the dimension, the area, efficiency, and the weight of the different collectors. The two 50-watt collectors, the big ones, completely block the rear view camera, the camera view to the rear. Therefore, they are unsuitable, unusable. We choose the red 20-watt collector because it has the best efficiency compared to the collectors 1 and 2, and it affects the camera view of the camera tower as little as possible. Here we see the camera tower. The design tracking unit has 1 rotation axis for the azimuth angle, this one, and 1 rotation axis for the elevation angle. The axis arrangement allows both angles to be set independently of each other, and each rotary axis is driven by a combination of a stepper motor and a worm gear with a reduction ratio of 30:1. This allows to increase the torque and to adjust the angles with a movement of 0.06 degrees per step. After alignment, the self-holding of the gearbox allows the stepper motor to be switched off. This behavior is necessary to ensure an energy-efficient axis drive. Here we see a collector rotated in azimuth and in elevation angle. The vector E shows the direction of the solar radiation. The angle theta describes the alignment difference between the surface normal of the collector and the solar radiation direction. The aim of the tracking is to keep this angle as small as possible. For the determination of the sun position, 3 different possibilities were considered. Possibility 1 is the calculation of the sun position from the date, the time, and the position of the rover, which this opinion, the collector can only be controlled in the direction of the sun. For regulation, a sensor-supported sun tracking is needed. For this purpose, there is possibility of a raster light measurement. This involves covering the area to be analyzed, shown here as a yellow quarter sphere with a grid. Then the light intensity is measured in each raster point, and the collector is aligned in the direction of the brightest measurement point. For the raster measurement, it is possible to mount the sensor on the collector and use the collector control. The disadvantage here is that the collector is not optimally aligned during the measurement, and the complete collector weight must be moved for each measurement. Another alternative is a sensor head with its own driven axis. The disadvantage here is the missing feedback of the collector, as well as the constructive additional effort for the sensor head. An alternative is the sensory direction determination. Here, 2 light sensors are aligned at the same angle to the collector, and the light intensity is measured at both sensors. The collector is then moved in the direction of the brighter sensor. This process is repeated in the control loop until the measured value of both sensors are identical or within an allowed deviation. At this point, the collector is aligned perpendicular to the irradiation direction. We use the calculation of the sun position to move the collector to the initial position at the start of charging, and then a tracking using the sensor direction determination. This picture shows the sensor holder for the directional determination of the azimuth and the elevation angle mounted on the solar panel. The middle sensors are used as a reference value and allowed an indication of the charging power. The higher the light intensity, the higher the electric power generated. This picture shows the control surface of the photovoltaic unit in the ground station. The ground station is used to monitor and control the rover. Here, the operation can start and cancel the loading process. The operator can start and cancel the loading process. The rover position can be specified by input. Alternatively, default locations can be selected, or the position of the global navigation satellite system sensor can be used. The control algorithm is programmed on a microcontroller with a real-time operating system FreeRTOS. The charging circuit consists of a 12-volt collector, a 12-volt maximum power point regulator, a boost converter, and a 22.2-volt lithium polymer battery. The maximum power point regulator is needed to keep the collector constantly at the optimum operation point. The boost converter boosts the system voltage from about 18 volts to the maximum charge voltage of 25.2 volts. On the right side, a graph with 100 measured values is plotted. The collector power and the charging power were measured. The red regression line with a correlation coefficient of R square equals 0.974 intersects the error bars of each measurement point. The measurement error is sigma equal plus minus 0.854 watt. With the equation of the regression line, the charging power can be calculated out of the solar power. Let us draw a conclusion. The developed tracking photovoltaic system is able to fully charge the installed lithium polymer battery in the month from April to September within 2 days. Through the tracking unit, a power increase of up to 44% is possible. The whole unit weighs 3.8 kilograms and can be mounted on the robot with 4 screws and 4 cables. Finally, we see a time-lapse video of the developed photovoltaic system in the test setup. For the time-lapse recording, 1 photo per minute was taken from 11 o'clock in the morning to 4 o'clock in the afternoon. At the beginning, the collector jumps to the calculated initial position and then continuously aligns itself to the sun. During operation, no malfunction of the collector occurred. The sun position was checked visually by eye every 10 minutes, and then the sensor valves were compared. No irregularities occurred during this process. The collector unit will be mounted on the rover for the next European Rover Challenge. Here I have summarized the image sources used for this presentation. If I could get you interested, visit our homepage or like us on Instagram. That's it from my side. Thank you for your attention. Do you have any questions?
Thank you very much for your talk. Do you have any question, comments, or remark? No question. Thanks again for your talk.
Thank you.
The second speaker is Diana Ikasari. The title of her talk is Determine the Shortest Path Problem Using Hora Algorithm, a case study of SMA zoning in depot.
Okay. Thank you, Mr. Emil, for the time. Can you hear my voice?
Right, sure.
Okay. I'm going to share my screen.
Okay.
Okay, thank you for the time that gives to me for present my research with the title Determine the Shortest Path Problem Using Hora Algorithm. It is a case study of senior high school zoning in Depok. Okay. The reason why we are doing this research is because the increasing of technology that makes people adapt a current have to adapt a current technology, and various daily activities depend on technology the digital technology that make it easy and fast in the process. It can save time and provide openness to the information provided and needed. And one of the field that uses information technology is in education, where during pandemic, all activities are carried out virtually. The teaching and the learning process or school enrollment. Okay, in this research, it explained the procedure carried out in the admission of a new student. Yeah, the new student admission with zoning system is a selection process that determine a student who are accepted in a school based on a zone or area which has been determined by the domicile distance to its schools. Okay, it based on our country regulation of the Minister of Education Culture that zoning area or the distance makes or create some it's been point. Yeah, the nearest is had 100 point, and the farthest is 10 point. Okay, and in this research, we use a case study in Depok area. Yeah, one district in Indonesia. Okay, West Java. There are 13 public high school that are registered in education and facilitation report on West Java, where the calculation of the distance between students' domicile and school point is the aim of the study. Okay, by getting the calculation of the distance from student domicile to its school, we be able to define which is the shortest distance. So result of this calculation, okay, the result of this calculation can be used as a school recommendation that can be chosen by student. And the Haversign algorithm is a method that can be used to provide a solution for the problem in the study. Okay, the Haversign formula is an equation that gives a large circular distance between 2 points on Earth based on longitude and latitude. Okay, that's why that's the reason why we doing this research. Okay, we have some research methodology. Here's this research which have several steps, where namely it's a coordinate identification, then collecting of the coordinates of its school. The next step is modeling the distance. We are doing the modeling the distance between the point. Next, we are doing some calculation of school distance. We use the Haversign algorithm here, and then we show the result of recommendation based on the distance. Here's only we just create some method that shown how to calculate the distance. Here's only a part of our research that still continue. We are still doing this research until we create an application. Okay, we are going to create some application on web-based. Okay, in the final research is we can give an application that the people can use or student can use, that that they can have a simulation for decision support system for where they are choosing their school. Okay, when with the research methodology for the first step, you are doing some coordinate identification. Here, the coordinate point identification is to determine the coordinate point of the student domicile, and then the coordinate point is obtained by activating the location on the browser and entering the address on the Google Maps. Okay, and then the second, collecting of the coordinate of its school It means that data collection on public senior high school in Depok, it based on education and facilitation report of West Java province, that we get the data from that it's mean the website. Okay. Next, then we are doing the modeling the distance between points. Okay, here carry out. Yeah, the process is carried out from the coordinate point of the student domicile each school. From each school, the result of this modeling we create on the table coordinate. We create the table coordinate. Every school that already exists in Depok. There are 13 senior high school. Yeah, and then we are doing calculation. Yeah, calculation of the school distance by using the Haversine algorithm. Yeah, here the shortest distance between 2 points on Earth is measured along the surface. Then it can be displayed on Google Maps. Okay, the Haversine formula here calculates the distance between the coordinate point of the student domicile to the coordinate point of its school, yeah, based on the length of the straight line using the longitude and a latitude value. Okay, this latitude is defined by the symbol theta, which describes straight line at a certain location on the equator, and longitude is defined by the symbol of lambda. Okay, and then the last step on our research methodology is the result of recommendation. Yeah, based on the distance. Here's the result of school recommendation based on the distance calculation using the Haversine algorithm. Obtain information on the distance from the student domicile to its high school. Okay, this information will be arranged for the nearest distance to the farthest distance. Okay, in order to obtain recommendation for destination school that can be selected based on the nearest distance. Okay, that's the research methodology. And here some formula that we are used for the Haversine method, that latitude and longitude we create, and then here's some formula that we use to calculate the distance. Here's there are formula number 4, 5 until 8, and here with simulation the result, the distance simulation. We just choose in this paper only we show only 3 school, but actually we already calculate all the 13 senior high school. Here's the student coordinate is there's a latitude here, and there's an address. We are using the Haversine method. Okay, then we calculate the distance. School distance calculation for the first school. Here's we got the number here, yeah, and then the school distance for the school number 2. We have here we have the number, and 3 with the formula we create, and the last we collect all the data, all the calculation in one table. Okay, here's there are 13 senior high school. Okay, the result here's actually in senior high school 13 here, the last in the table. This is the nearest, yeah, the nearest path or the nearest distance for the student, which is have a latitude and longitude here. Okay, and then we are doing some what is it, comparison, yeah, between the calculation the distance using the Haversine. We try with the Google Earth, and here's the table we collect the data, it's obtain the accuracy of the effective result that there's no big difference for the distance. Yeah, it's part of method that we are using in our research. Okay. Then here we can conclude that Haversine algorithm can be implemented to solve the problem, yeah, of the determining the choice of school recommendation based on zoning. Okay, and the solution is done by calculating the nearest path between coordinates of the student domicile and the location of destination of school, which is sorted in a ascending order with a scope that has been limited to a certain radius. In the study, we use the zoning in Depok City, okay, in Indonesia. Yeah, that's my presentation. Is there any question here?
Thank you very much for your talk. Any question? Comments? Or remark? No question? Everything is obvious. Thanks again for your talk.
Okay, thank you, Mr. Amir.
Now, the next two presentations will be given by Dr. Diana Kinaneva. The title of her first talk is Machine Learning Algorithms for Regression Analysis and Predictions of Numerical Data. Her second talk is a workflow for developing game assets for video games.
Hello, everyone. I hope that you can hear me well.
Yes.
Okay, I will just sharing my screen now. Okay, can you see it?
Yes.
Okay. So today I'm Diana Kinaneva, as I was presented. Nice, thank you. And I'm from University of VROOM3, which is in Bulgaria on the Danube River. And today I'm going to present you machine learning algorithms for regression analysis and prediction of numerical data. In the paper, we include an introduction about the applications that we use widely today and are powered by artificial intelligence. Then we continue with a review on some of the most popular algorithms used for regression analysis. And after that, we evaluate them on a database in order to see which algorithm perform best in terms of accuracy. I'll give some examples of where we find artificial intelligence in our daily used applications. But before that, let's define the term artificial intelligence. Artificial intelligence has become extremely popular in the recent years, although it has a story dating from the time of Alan Turing. Artificial intelligence has the ability to perform tasks that are inherent to a human mind. And behind the artificial intelligence stands machine learning algorithms. The machine learning is the field of study that gives the computer ability to learn without being explicitly denied. When talking about artificial intelligence, people usually imagine humanoid robots, but artificial intelligence indeed is more widely spread among different applications and in different forms. Back in the 50s, Alan Turing, the famous English computer scientist, lays the foundation of what we now call artificial intelligence, although the term was not defined at that time. Turing addressed the problem of artificial intelligence and proposed an experiment that's become known as the Turing test. The experiment is an imitation game in which the goal is to be determined whether a computer is capable of thinking like a human being. From then to now, artificial intelligence grow up, and now people communicate with computers via virtual assistants. Virtual assistants are not only personal supporters who answer questions and perform actions via, for example, voice commands, but they also perform tasks or services on behalf of individual based on the combination of user inputs and location awareness. They have the ability to access information from a variety of online sources, to remember user preference, and to offer new services based on these preference that they learn. Among popular virtual assistants are Cortana, Siri, Alexa, Bixby, Google Assistants, and many more. Google, the American giant in the area of technology, also uses artificial intelligence for all of its services. Actually, Google declared itself as a company that first used machine learning algorithms for implementing a kind of artificial intelligence. One example of a Google application that uses artificial intelligence is Google Maps, the navigation system. As people traverse over 1 billion kilometers with the help of Google Maps, in more than 220 countries, they generate statistical information that is used by Google Research Lab to train their machine learning models that are able to predict whether the traffic is heavy or light, an estimated travel time, an estimated time of arrival. And by using this approach, Google aims to improve the traffic prediction accuracy. And according to the latest observation, the predictions have been consistently accurate for over 97% of the trips. Google searches are also driven by algorithms for machine learning. Now, Google search has the capability of semantic search and neural language processing that allow Google to understand the intent of the search query. On the other hand, the most powerful tool used to socialize the people around the world is the language translator. The modern artificial intelligence-driven translator offers services such as syntax, speech, language, and image recognition, which significantly improve and smooth out the conversation between different native speakers. Google Translate relies on computer vision mechanism, on the other hand, that allow it to recognize text in images and thus perform the translation as it is seen on the slide. You may probably use this functionality of Google Translate. It's very helpful. Image recognition or detection of a particular object in an image is a branch of artificial intelligence that is widely used in many areas. For instance, you probably see this type of image recognition in the social media Facebook, which uses a tool for Facebook when they are not tagged in. And these two use deep convolutional neural networks that are pre-trained with images which are uploaded by Facebook users. And the algorithm finds similarities and uses classification to predict where the person is present in the new images that were never before seen by the program. We now notice that the list of artificial intelligence-driven applications can be long. They can be given more examples, but this is enough to show how artificial intelligence become an integral part of our daily habit. For us, the scientists, the more important is not to find where the artificial intelligence is used, but how to implement and improve on new algorithms for AI-driven application. And as it's already seen, behind the artificial intelligence stands machine learning algorithms. They can be categorized into different groups depending on many criteria. For example, depending on how they are trained, they are supervised, unsupervised learning algorithms. For the group of supervised learning, we can distinguish regression and classification algorithms. The main difference between the two is that the output variable in the regression algorithm is numerical or continuous, while the classification algorithms are categorical or they are discrete algorithms. In the paper, we evaluate the accuracy of several different algorithms for numerical data computation or for regression analysis. The first algorithm we evaluate is simple linear regression. The goal of linear regression is to fit a straight line across the parameters. Since it is supervised learning, algorithm uses input-output pairs, which in the figure are showed with blue crosses, in order to find linear function f of x that best fits the known pairs. That function is further used to predict. The function is further used to predict this data by building a hypothesis function. And this hypothesis function is given by the expression f of x, or hypothesis of x, is equal to θ0 minus θ1 by x, where θ0 is the value of y at x equal to 0, and θ1 define the slope of f of x, the slope of the line. Linear regression is called linear in case of having one input parameter. Often in practice, one parameter is not enough to build a good hypothesis model that can predict new values. In such cases, more than one parameters might be used and passed as inputs. In those cases, the algorithm is called multiple regression. The algorithm examines how multiple independent variables are related to one dependent variable, the value that should be predicted at the end. And this relationship between dependent and independent variables given with the equation θ0 plus θ1 by the first parameter, θ2 by the second parameter, and so on and so forth. And the benefit of using multiple variables instead of only one to build a model is that we can more independent variables. In general, will explain of the variation in the dependent variable, but using multiple variables to multiple regression procedure does not always mean that the regression will be better or the prediction will be more accurate. And in order to best fit the model, not to overfit it, but to best fit it, only the significant values, variables must be selected. And in order to select the right variables, there are 5 methods for selecting them. And they are listed here. These are all-in. Actually, all-in select all the variables, doesn't eliminate any of it. We have backward elimination, forward selection, bidirectional elimination, and score comparison, which choose a significant variables based on their p-values. Simple linear or multiple regression are not always the best models for the data because not all data follows a straight line. For such data sets, a polynomial regression might be a better choice. Polynomial regression adds extra independent variables to the equation that are powers of the original variables. The regression analysis generates the following equation: θ plus θ1 by x plus θ2 by x powered by 2, and so on, until we get the right prediction. A benefit of using polynomial regression is that it can fit a broad range of function, fits a wide range of curvature, adding more independent variables with the powers of the original that has variables which are nonlinear. But there is also an issue. At some point, the model can overfit the data. There are also other algorithms that we evaluate. For example, supported vector, which is a popular machine learning algorithm that is used not only for the regression, but also for classification. Actually, it's more often used for classification that fits categorical data, but in some cases, it might be very helpful in regression. There are a few important parameters. These are kernel, hyperplane, and decision boundaries. And the objective of a supported vector for regression, or let's say it as VR, is to basically consider the points that are within the decision boundary line. And the best fit line is the hyperplane that has a maximum number of points. Another algorithm is decision tree. It's also used both for regression and classification. The algorithm builds a model in the form of a tree with decision nodes and leaf nodes. A decision node has 2 or more branches, each representing values for attribute tested. A leaf node represents the decision on the numerical target. And the basic behind the algorithm is that it separates the data by asking a question. And each question narrowing the possible values until the model gets confident enough to make a single prediction. The main function of the decision tree regression algorithm is to split the data into a smaller test, which in programming language is just an if-else statement that are used to predict the result based on the data. Another supervised machine learning algorithm used for nonlinear regression is random forest. Random forest is an algorithm which is very similar to the decision tree because it actually builds many decision trees. So instead of building a single tree, a random forest uses multiple trees to predict the output. And the actual predicted value is the average of the outputs for decision trees in the random forest. While decision tree tends to overfit the model, random forest prevents this by creating random subsets of random forest regression algorithm. It also tends to overfit but only for some data sets, which has a noisy regression task and has many other advantages that compensate this drawback. It is one of the most accurate learning algorithm available and runs efficiently on a large data set. And now for the experimental part, we have used data sets for estimating a wine quality based on different variables. There are a total of 11 independent variables and about 160 examples in the data set. We have set aside 20% of the example and used them for estimation of the accuracy of the model. These 20% will not be seen from the model until it is fully trained. And for the experiment, we have used R programming language for 2 reasons. First, it's free software environment for statistical computation and graphic. And second, it is intuitive and good for data miners for developing statistical data analysis. And the results of our algorithms are shown on the next slides. Since our data sets contain 11 independent variables, we do not consider simple linear regression. We started with the full multiple regression. There are some issues to consider. As mentioned, to get better prediction, the model must choose only significant values. And for selecting only significant values, we have used backward elimination technique. After implementing backward elimination for this algorithm, only 6 independent variables from the total 11 left in the model. And here in the slide, we see the difference between actual and predicted values from the multiple regression model. We choose the examples from those 20% that we set aside from the training. So the model was first trained and then tested on this 20% of examples in the data set. As we see, the actual values from the test sets are plotted on x-axis, while the predicted values generated from the regression are plotted on y-axis. Has never seen the values there. It can be concluded that the model accuracy is good, but it's not perfect the dots are spread vertically because the values of quality for the wine, the dependent variables, are integers, and they have to be concentrated around the red line, which actually represent the best fit. The red line is plotted by us just to see how the fitted line should look like. And we see the predicted line, which is the gray line, is a little bit close. It's not so close to the red line. The slope is different. For the next algorithm, supported vector regression, the output is quite similar to the output from multiple regression. Again, the model is not best fitted, but it can be noticed that it performs a little bit better than multiple regression. We notice that the fitted line tends to correct the slope. It is more closer to the red line in this algorithm as we are. The best result we managed to achieve with decision tree algorithm are illustrated on the following slide. We have tested fitting the model with all the independent variables, and we selected ones, and we have noticed that the feature selection worsened the model prediction. For this reason, we have chosen to fit the model with all variables without performing feature selection. Actually, for regression trees, we call it regression tree because they are decision trees used for regression. Feature selection is not required since they have internal intuition which features are significant and which are not. So here we build the regression with all the variables. And we see the last algorithm. We have carried out experiment. Random forest has built many trees as the user defined. We have tested with 2, 5, and 10 trees, and we have noticed that this algorithm performed the best according to the rest algorithm tested. As we see, the random forest best fits the light gray line. It's almost matching the red line, which is the ideal fit. And as much the trees are, as we see, as much accurate the black dots are plotted next to the red line. So as a conclusion, we summarize our efforts. We managed to analyze several popular algorithms used for regression analysis on publicly available database. For the database chosen, we found that the random forest algorithm best fit the prediction model. We do not argue that it's the best algorithm for such analysis, but for the data that we use, it performs best. Other interesting algorithms that have popularity too are those used for classification, and we are planning to perform the same experiments, the same evaluation on algorithms used for classification as well. Because in most modern machine learning implementation, most of algorithms are used in combination to perform a complex task and to achieve goals of artificial intelligence, such as those seen in the application before on the first slides. Thank you for your attention. If you have any questions about this paper.
Thank you very much for your talk. Do you have any question, comments, or remark? Just, I have one question.
Yeah.
How artificial intelligence, machine learning, and deep learning differ from each other?
Well, basically, deep learning is called to machine learning, which uses neural networks, which has multiple secret layers. And this is the main difference, while the machine learning is the most common term describing the algorithms.
Okay, thanks again for your talk.
Thank you.
Diana, the duration of presentation is 10 minutes. Please check the time while
Okay.
your talk.
The
Okay,
following one is a little bit.
Have another session after this session ends. Okay.
Okay, I'll try.
Okay, thank you.
The
Now we
next,
can present.
yeah, the
You
next
can present.
yeah. The next presentation is a bit shorter, so I'll try really to be very fast with it. It's about workflow for developing game assets for video games. And as an introduction, we describe the main pipeline followed when developing a game assets for video games. And nowadays, games industry has huge popularity and even conquer with Hollywood and movie industries. Game developers and artists can make things look realistic with significantly reduce the efforts of creating spectacular movies. Behind every impressive games, there are thousands of hours of hard work done by various designers. We discuss the stages of the workflow for developing game assets for video game. The stages are presented as layers, as you can see it on the slide. We pay more attention on the most challenging steps from the pipeline. The workflow starts with the initial concept, which reflects the main idea of the designers. With the concept, they distribute the tasks to achieve their goals. And after the concept is cleared, the actual implementation of the project starts. And the first step of the game assets workflow is modeling. It requires a solid knowledge of how to work with specific software, modeling products, and good skills to achieve the desired goals. After the model is ready, the designers add materials and texture on its surface to make it look more natural. And then the model is rendered in specific virtual environment, and if necessary, they further improve to achieve realistic effect. Creating three-dimensional object is a process that uses various techniques and tools. Here you see the first technique that we describe in the paper. One of the most common technique is box modeling. It is called so because box is associated with the most common geometric shape, which is a cube. And in this technique, modeling begins with a primitive shape, most often a cube, but it may also be a sphere, cylinder, and other. Basic shape is then used to sculpt out the final model. Techniques such as extrusion, scaling, moving, polygon, or vertex rotation are used. In the slide, we see an example of box modeling of a model created by our team. Among popular software products that offer box modeling and this kind of tools for building a model are 3ds or 3D Studio Max, Autodesk Maya, Blender, Cinema 4D, and many others. The two most common tools for box modeling that are used in almost every model are extrusion and edge or cut loops, with actually a kind of subdivision. Other technique for modeling is called polygonal modeling. It is very similar to box modeling since it uses the same tools. The only difference is that the polygonal modeling begins with a single vertex or simple shape such as plane without any depth on it. And another modeling technique is called digital sculpting. This method is more often used for creating organic shape, such as character, animals, people, or creative design. It is more like artistic modeling than engineering of 3D modeling. The focus is on the shape of the model and its detail. That would be hard to create with the other techniques described before. One of the main challenges of sculpting is that it removes the focus from the topology, which means that there is an opportunity to think more about the shape, design, and visual qualities of what is building. But at some point, the topology must be revisited. The increased number of polygons directly affect the performance of its rendering in the game, because each polygon must be rendered individually. There are other techniques for creating 3D content. These are photogrammetry and 3D scanning. Both technique uses the principle of triangulation. 3D scanning is a technique which requires the use of specialized equipment in terms of 3D scanners. And there are different type of scanners. Here on the slide, you see our collection of 3D scanners. We own the whole series of Artec 3D scanners with a high professional scanners used for reconstructing real objects. One of the most popular type of scanners is those with structured light. These scanners constructed with light projectors which emit pattern line on the surface of the model, and the line pattern is deformed in accordance to object surface. On this way, the scanner captures information about the object surface and its shape. And the good thing is that the 3D scanners can also capture color information, and they can add easily texture on the model. Photogrammetry is the second technique for reconstruction of real object. It also uses the principle of triangulation. A point from the 3D space is projected in two frames, and thus a triangle is formed. And then the sinus, cosinus, and Pythagorean theorem, as well as the property of the angles of the triangle, are used to calculate the position of each point into the 3D space. And after the first step of the photogrammetry algorithms complete, it generates a point cloud from which at the next stages the mesh is built. The advantages of using photogrammetry as a technique for creating 3D content is that texture can easily be added to the model surfaces. The camera captures the color information of each point of the object, and on this way, more realistic 3D models can be created. Of the workflow is the process of 3D modeling. Different techniques might be used for building a model. When modeling from scratch, designers usually use reference images or concept art, which helps them a lot to achieve the desired products. The reference images helps artists also to clean up their ideas. By using many reference images, the designers create a concept art, which will be used as a template for creating the model. And these reference images, as you see, can be personal photos collected by the authors. In the slide, we see how designers prepare for modeling an X. This is a model that we have built it, so that's why we give this example. An X is a game asset that could be used for forest scenes, for example, or stand where there are fireplace, or many others, for example. These reference images are used to draw the concept art, which is shown on the right upper corner. The conceptual art is used as projection reference in the software for 3D modeling. The models are first created as a low poly meshes, which consists of relatively small number of polygons. And these models use less computational power and resources to render, and they are more suited for engines that need rapidly calculate the model reaction to the virtual environment. However, producing high quality render requires the use of high poly modeling, and very often low and high poly models are built for the same object. High poly are used to build a detailed texture on it and then apply it to the low poly and look more natural and realistic, and at the same time to have fast rendering to save computation. After the geometry of the object is model, it's time to transform it to a realistic model by adding material or textures on its surface. The texture by itself is an array of colored pixels that form an image. This image is wrapped on the model surface, and thus the model becomes photorealistic. And in order to apply a texture on the model surface, the model must first be unwrapped. And this is done in the modeling software by the appropriate tools. The material reflects the structure of the model surface, and some texturing program uses layers with each layer affecting the material in different way. Other uses a series of connected nodes. The difference between materials and textures is that material is all the properties that make up the object looks. Its color, bumpiness, glossiness, roughness, and so on. A texture is placed onto a material for one of these effects. So many textures make up a material. The material is one, the textures are many. And these textures can be hand-painted. They can be taken from photos. For example, if we use a photogrammetry, the textures are taken from the cameras, and also that they can be procedurally generated by getting the computer to make the texture. There are two types of materials, basic material and PBR materials. PBR is physically based rendering. Basic materials are simple material which do not react to environment, and in terms of realism, they are a bit limited. On the other hand, PBR materials are designed to react to the environment, and they are very realistic, and there are very several main textures for PBR materials. The first is color. The color is defined by diffuse or albedo texture. The albedo specifies the color of the surface and determines the main reflectivity of the material. And the difference between the two is that the albedo texture does not contain information about the light, while the diffuse, as you see, contain. Other textures, displacement, bump, and normal map, do the same thing but in different way. They create something that looks like extra resolution, bringing more details to the model. Bump and normal textures do not change the geometry of the model. They give the false impression of greater resolution only on the material but not on the geometry, which is good because the render time will be faster. The technical way these textures do the illusion of depth and features is they tell the computer which direction light needs to bounce off the object, as shown on the above figure. Displacement map also adds detail to the model, but it does it by adding more polygons to the geometry. So displacement, again, the extra resolution look, but it adds more polygons. It's to it by the geometry change. The next texture, which is used in PBR materials, is the metallic map. It gives the ability of the model surface to reflect the imagery around it. Metallics are either represented as black and white, where black means no metallic look, as opposite to white, complete metallic view, or they can be represented in grayscale. What does this mean for the rendering software is that if the metallic map is white, a large amount of light will be reflected from the surface of the model during the rendering, which will lead to metallic appearance of the object. The ability of the model surface to reflect or absorbs light white is achieved by roughness map. And in some render engines, it may also be smoothness or gloss. The rougher the surface of the model is, the more diffuse the reflection light will be. The reflection of light from a smooth surface is more concentrated. Roughness maps are also defined as black and white images, and often the terms gloss and reflectivity are confusing. The reflection, the amount of light that returns is instead of absorbs, while the gloss determines how blurred the reflection will be, but not how intense it will be. And the last texture used to improve the look of the model is called ambient occlusion. This is a technique that computes how exposed is each pixel from the ambient light in the scene. An ambient occlusion texture determines which areas are inherently darkened and simulate the shadows in the scene. In the slide, you see an example of adding materials to the model of X. It illustrates how different textures change the appearance of the object. In order to achieve the final realistic look of the model, different textures are added. These are base color, bump map, roughness map, metallic map, and ambient occlusion. And in the paper, we present the workflow for developing ready-to-use game asset. As it can be noticed, the workflow contains complex stages with many tasks for which good knowledge of 3D modeling, texturing, also animation, sounding, and others are required. The assets are ready to be used by game engineers who work is related to assembling the game sense and building the game logic. Many times in practice, these engineers prefer downloading or buying game assets instead of wasting time to create them. And the assets are further uploaded to a public stores or databases from where the game designers can download and use them. Thank you for your attention. If you have any question about this paper, I'll be glad to answer.
Thank you very much for your talk. Any question or comments? No question. Thanks again for your talk.
Thank you.
Next speaker is Elena Angeleska. The title of her talk is Methodology for Bio-Inspired Design Innovations Based on Functional Decomposition.
So, hello to everyone. My name is Jelena Jokic, and I will be presenting the paper. Just to share my screen. Can you just confirm me if you can hear me and you can see the presentation?
Yes, we can hear you and see your presentation.
Okay, thank you very much. So our paper is regarding methodology for bio-inspired design innovation based on functional decomposition. Authors are Professor Sofia Sidorenko, Elena Angeleska, Filip Dimitriev, and myself, Jelena Jokic. So bionics is, or biomimicry or biometrics is a principle of nature-inspired design used in the process of designing innovative products. There are two main approaches used in the bionics, and that's top-down approach and bottom-up approach. Top-down approach is the approach when you have first identified the need or the design problem, and then search through the natural phenomena for solving this problem. Opposite to that is bottom-up approach, where you have specific natural phenomena identified, and then search for design areas where it can be applied. What is most commonly used in the practice is a bidirectional method that combines these two approaches. In our paper, we will be presenting a specific methodology for bio-inspired industrial design innovation. So in our methodology, we are using the bidirectional method, but also we are combining with the principle, Ullmann's principle for design processes. So we have two input elements, that's defining the user needs and functional analysis of the final product. And as you can see on the picture here, both of these can be implied for the top-down strategy and again for the bottom-up strategy. So in order for us to better explain this methodology, we have one design case that I will be presenting here for you. Basically, we are following the bottom-up six-step strategy for applying and identifying functionalities of the natural phenomenon and applying to the product. And this project is based on the biotensegrity as an inspiration for the design of the innovative product. So we have identified the natural phenomenon, and that's the tensegrity of the spider's web. Among the other functions that the spider web can have as resilience, distribution of kinetics energy, and stickiness. We choose the tensegrity because it has unique characteristics. It has high strength, it's flexible, and it has unique distribution of kinetic energy. So for the next second step, we are analyzing this natural phenomena with the questions what, why, and how. In the interest of time, I will be in depth explaining only one example. For example, we have the tensegrity, which is establishing the integrity of an object by creating tension. And why we are choosing this function? Because it's maintaining strong and stable webs. And how is doing that? Only one silk strand is composed of thousands of parallel nanostrands, which gives it the strength. So for the third step, we have conducting a research for particular issues people may have or a specific problems that can be solved. So what needs to be done and why? We are applying the principles of tensegrity in the design of a product in order to achieve a unique composition and aesthetics that defies gravity and contradicts the usual laws of physics. And what can the biofunctionality solve? Redesigning typical commercial products for everyday use in order to modernize them by using the novel technologies and bionic principles. This way we can make more concurrent products that will follow the contemporary trends in the design and technology and can meet them. The fourth step is organizing the gathered information of the design problems that can be solved by the natural solution. Again, we have the questions what, why, how, but this time these questions are concerning the product functions. For example, we chose to redesign desk lamp. Why? Because in order to achieve an untypical design with the application of contemporary technologies and bionic principles, and how we are identifying the biofunctions tensegrity by applying it to the design of the lamp. The fifth step is defining the how column. So we are doing this by incorporating a strand composed of spider silk imitation material and positioning to connect the lamp base and the lamp light shade. The positioning help to achieve the constant tension and compression presented in the creation and implication of the silk and keep the light shade in place. The final step is where you present the product concept, and you can see our concept on the picture here. So the strand that you see is the strand that is actually inspired by the spider web with the front end pushing it down and the back end of the lampshade going up. So we use the tensegrity to have it to have the lampshade in place. So as a conclusion, we use this approach to our methodology that can be used to in designing new innovative products. During our work with students at the Faculty of Mechanical Engineering, we found out that this methodology is also successful in the process of teaching students how to gather inspiration from nature and develop creative solutions. The main strength, according to us, of this methodology is the neat organization, because it's combining the creative process with the engineering process, as Ulma suggests. And the end goal of this method is to establish a biodatabase of redesigned functions found in natural phenomena that can be respond to different product function. And we believe that in short time we can have this biodatabase, since as I already mentioned, we are working with our students on this. Also, finally, this proposed methodology helps designer and design students understand bionics and standardize their work for developing bio-inspired design innovation in order to make it more efficient and engineering oriented. Thank you very much. If you have any questions, I will be happy to discuss them. Thank you.
Thank you very much for your talk. Do you have any question? comments or remark? No question. Thanks again for your talk.
Thank you.
Next speaker is Elizabeth Zagan. The title of her talk is Cloud Data Lake, the New Trends of Data Storage.
Hi, hello. Can you see my screen? Okay.
Not now. Now, yes.
Okay. I'll try to. Okay. You can see it full screen. Okay. Hello, I'm Elizabeth Zagan, and I'm a PhD student from the Ștefan cel Mare University of Suceava, Romania. And my paper title is Cloud Data Lake, the New Trend of Data Storage. The presentation is structured as follows. In chapter 1 is a brief introduction. In chapter 2, I will discuss about the 4 types of data lake architectures. In chapter 3, I will present the main advantages of building a data lake in cloud. And finally, in chapter 4, the main conclusion are drawn. In this paper, I presented a study made about the newest technology that stores and manages the big data. As we all know, everything nowadays is based on data. The explosion of new data such as social media, finance, commercial, healthcare appeared in recent years had led to the emergence and the development of new technologies and techniques of data management. The large amount of data has brought with it the need for significant changes in the architecture of storage and processing systems. The old technologies of data storage and data processing are beginning to be overwhelmed by the large volume of data and their variety. Along the way, with the help of new technologies, new adaptive hardware and software systems have been deployed to meet the new requirements for big data storage and management. More than 50 years ago, there were few third-party dataset processing solutions, but as the capacity of generating data increased, the need for data storage and processing has also increased. Lately, in database field, the concept of data lake is increasingly common, where data lake is a modern rough data storage technology that brings many advantages, due to the fact that within a company, it allows the absolute storage of all data in their raw format, so that it can be subsequently subjected to advanced analysis processes to obtain crucial information unforeseen at the beginning of the storage process. In this figure, we can see the structure of a data lake at a conceptual level, where we can observe the data acquisition level, where all kinds of data types such structured, semi-structured, and unstructured are ingested into the data lake in their raw format. Based on schema-on-read technology, the data curation and data transformation level comes after the ingestion process. And above all this, we will find data analytics and the reporting level being subsequently accessed by all types of search engines available on the market. The cloud data lake is more than just storage. The cloud data lake is a complete analytical environment that supports a variety of analytical tools and languages like SQL, R, Python, Java, Scala, supporting a variety of workloads from traditional analytic, business intelligence, Internet of Things, to advanced machine learning and artificial intelligence processing. Data lake architecture can be implemented in several ways. It all depends on the choice of the architecture that best fit the need of a business based on costs and hardware and software resources. First, we mentioned data lake on premises. Is the data lake physically deployed locally that requires the management of both hardware and software technologies. The major disadvantage is that this double task requires major engineering resources and experts in the field who need to improve their knowledge with new and rapidly evolving technologies. The most common technology used to implement a data lake on premise is the open source Hadoop framework from Apache. Next, we have the cloud data lake. Is a next generation data lake hosted in cloud. The major advantage is the immediate availability of creating a data lake. Each cloud services providers offers complete tutorials about their own services. Among the largest cloud services providers who have managed to deploy and deliver high-performance data lake solution, we mentioned Microsoft Azure, Amazon, Google. Then we have the hybrid data lake that allows data lake to be maintained locally as well as in cloud, which can present a number of benefits, but also a number of challenges. The major advantage is that less relevant data can be stored locally to reduce storage costs, taking advantages instead of the cloud speed services on important data. And the last, the multi-cloud data lake. This last type of data lake architecture is the one that proposes using combined cloud services from different providers. For example, there are large companies that use both Amazon and Microsoft Azure providers to manage and maintain data lakes. Having multiple data lakes on different cloud platforms means benefiting from advantages of each platform, but requires greater technical skills to achieve the communication between them. Mostly the data lake term is associated with Apache Hadoop, the data being stored in HDFS clusters that are physically only locally within companies. Unfortunately, many of these local data lake projects have failed to successfully complete a reliable architecture due to the complexity of implementing such an architecture and the great efforts of managing the entire system. Data lake must provide services for ingestion, processing, analyzing, and securing all types of data in one place. Cloud technology have evolved so much recently that data lake in cloud is in some ways beyond the data lake on premises. In recent years, many companies with large volumes of self-managed data on platforms such as Hadoop tend to migrate to cloud due to the many advantages we will highlight below. Moving data to the cloud today has become an affordable technique for all businesses of all sizes. Among the major advantages, we can mention storage capacity, that in the cloud, the storage is unlimited. Cost effective, cloud storage providers offer different services at different costs. This helps companies pay for exactly the service they need at the different stages of development. The central repository, the cloud has the advantage of a centralized location to store all types of data that can be accessed from any location. Another advantage is data security. All companies have the major responsibility to protect their data. Cloud service providers guarantee data security according to the shared security responsibility model. The automatic scaling, modern cloud services are designed to provide immediate scalability of data, so businesses don't have to worry about expanding hardware capacity when needed. Another advantage of cloud services is the user-friendly interface at any level. Among other advantages, we can remember the lower startup investment. The latest versions of software are available on cloud at no cost and effort. In terms of costs, over time, cloud providers charge companies for storage on time rather than size. Over long periods of time, a cloud may be more expensive than a local storage. This remains to be assessed by each company according to the possibilities for local management of a storage environment, as IT experts in the field in some region may be difficult to find. So implicitly, there will be higher costs of creating and owning a full team of reliable experts to provide high quality services. As we can see here with Cloud Data Lake, we can save up to 77% of costs compared to data lake deployed locally. In conclusion, regardless the type of the architecture you choose to build a data lake, we can say that for companies that want to discover the benefits of a data lake, they can start with the services offered by cloud providers. Following the experience gained on the cloud, it will be possible to correctly assess the need of implementing a data lake locally, taking into account the costs, the implementation time, and the complexity of such an architecture. Thank you and for your attention. And if you have any question.
Thank you very much for your talk. Do you have any question, comments, or remark? Thanks again for your talk.
Thank you.
No question. Okay, the last talk of this session will be given by Emilia Georgievska. The title of her talk is Content Engineering for State-of-the-Art SEO Digital Strategies by Using NLP and ML.
Hello, everyone. Can you hear me well? I'll try to share my screen now. Okay, just to see my presentation. Share. Do you see everything correctly? Everything fine?
Yes.
Okay, so merhaba Turkey. Nice to be here. Thank you for the opportunity. I want to use this opportunity to thank my mentor and collaborator, Professor Dr. Georgina Mircheva. Our topic is content engineering for state-of-the-art SEO digital strategies using NLP and machine learning, something that we believe that it's not about us. I'm Amelia. I'm a computer science and SEO engineer. I have a mix of skills: IT, marketing, growth, teaching, product development, and research. I'm in the media world more than 10 years. I'm currently working at Meinerstadt.de, which is part of the largest digital publishing house in Europe, Axel Springer. And I'm working at their Martech team. And on the right is my mentor and collaborator, Georgina Mircheva, associate professor at the Faculty of Computer Science and Engineering, UKIM Skopje, Macedonia, PhD in computer science. And her research interest is focused on artificial intelligence, data mining, multimedia, machine databases, and biology-related topics. So why this topic? Now, the thing is, how we value and define customer experience and how we, what we do about it and how we find people online and how they find us and how we present to them our solution changed a lot in the past year. So this is the topic of SEO. If you're not familiar with the acronym, it means search engine optimization. And by the end of the last millennia, it was something that people thought, okay, so if I do search engine optimization, I don't care about anything. I know about some sort of page rank rules where I care about ranking and I care about link building. So I want to find people that are going to link to me because it was so easy to game the system. The algorithm was were not advanced and it was completely different times. So I'm really happy to be able to start working in a very different era where we do care about what user wants and we care about taking feedback, but also all the IT components in the process, like having good software development practices and good website optimization and web design, but also some holistic strategy involved here so that we are really sure that we understand where we're headed in. And the thing is, if we need to summarize all these topics somehow and what the hypothesis in on our research about our users, about we are some sort of media company because we need to entertain. We also need to publish different type of content, different formats for the goal of selling something, meaning we need to have some sort of a commercial goal that is involved here. So ideally, we want to use all these aspects, data, media, and commercial goal to try to organize them somehow in a certain way. You will see how in the following slides, so that we can improve the user experience and therefore increase our sales. Something that people define that it is low. Like I said, the algorithms were not advanced in the beginning, and you didn't need to know a lot about how search engines work and so on. But nowadays, the situation is changing. Like I said, we are having a lot of data, a lot of competitors, and now we are all international and so on. And it looks like that we are more moving on the data science field. This is only one part of it. So ideally, I think that SEO should be here. The industry currently is at programming level, trying to upskill, trying to learn new ways of how can automate some stuff and so on, so that we can use our data that we have better, understand the users better and so on. So is SEO still just search engine optimization nowadays? Absolutely not. The shift is here. It's happening because we have all this data that is dispersed in different sectors. We have large company, it will be divided in multiple teams. Or if you have a relatively smaller company, you still have different people that need to be gathered together to collaborate in a certain way, so that you will have a unified picture on the whole process, on the whole user experience, and use data analysis tools and collaboration and different aspects of the whole strategy, so that you are sure that you're providing the best possible experience, whether we're talking about technical optimizations, content optimizations, and so on. Because the user is the focus, we want to understand what his problems are, what does he want to see or not, where he struggles, and so on. Now, semantic SEO, it's very complementary nowadays with some concepts that are familiar to us in the IT world, in the IT industry, let's say, with decades already. We know about this stuff, but the thing is that they just didn't manage to come to the marketing world. So people now here are learning about what entities are, and eventually what are the relationship between these entities, and how can we use URIs to point to stuff, or maybe resource description frameworks and ontologies, and how that relates to links and using certain words and phrases so that we can describe topics. All these concepts are related, and like I said, we know about them, but they did not manage to come to the market world. Now, in the SEO industry, for example, if you have a platform or a website, you will care about different metrics that certain analytics tool, for example, Google Analytics, the process for certain solutions. So one very standard can be page view, how many views you have on a certain page. It can be how much time does the user spend on the site. It can be something like how many pages did he click through while he was visiting our site, and so on. And the problem is that the typical analysis process consists of the following thing. You gather all the URLs from your platform or your website, and you try to analyze them this analysis. However, site that has multiple, let's say several hundreds of web pages, you don't really know what is the most important part, entertaining, profitable for the user on a topical level. And this is where the mindset shifts, because our content writers in the process, when they write content article, they rarely take care about labeling that article with the appropriate topic. So for example, if you increase your content efforts over time, let's say that you started writing a blog about machine learning, and then you start talking about unsupervised and then supervised algorithms, and then you expand it on certain clustering algorithms, and the discussion goes on. You can see that over time, certain topics become subtopic instead of a topic, or maybe 2 or 3 articles that existed independently need to be combined together. So this is not a linear process. I mean, it's very, very difficult to do it manually if you want to categorize all your content that is on your website. When I say content, certainly refer to an article or a web page that exists on your platform or website. So the solution lies in applying cross-functional thinking, or combining, taking a person that has cross-functional skills so that he or she can understand whether the problems are that involve multiple sectors, people working together, or make a framework, a certain way of different people from different departments work together in order to apply known technique to a new type of problem. In this case, it's SEO and it's marketing. The idea is the marketing and IT are going to marry, let's say, finally together. They're going to be stronger, and ideally and realistically, actually, we're going to see more hybrid positions in future. What used to be marketing and definition of marketing is not going to be the definition of marketing anymore. Maybe certain terms and certain names of industries are going to rebrand themselves in future. Why we want to do topic clustering? It's not just because we want to understand which topics are the most interesting for us to concentrate our content efforts on, but ultimately also for the idea of learning, how can we use this knowledge to interconnect all these pages together based on this semantic similarity? And this is very, very important. In this case, we decided to choose the approach for hierarchical clustering. Why? Like I said before, you can start with the topic of machine learning, and then you can develop a top-down into supervised and unsupervised, and you can see that there's a main topic on the top. Exist in the in this whole idea of working on a topic clustering and content organization is that, like I said before, there's a lack of documentation that exists inside content and SEO teams. So you cannot use their insights, their labels, their knowledge in order to organize that. Type of, so what will be the topic of that text? Is it going to be politics? Is it going to be a news article? Or is it going to be marketing? Because it's a peer tradition, which is in the past, there's also legacy infrastructure, but also legacy in a way how marketing and SEO people approach certain challenges, whether they're about connecting the right articles between themselves and so on. Example, if you take data from a targeted website, can be that you know about potential DNS attacks, or maybe how fast you're taking your data out of there. Are you going to overload the servers with requests? Or maybe the scraping framework that you're going to use, what kind of parameters are you using there? Are you doing everything to optimize the process? So these are different types of challenges that need to be considered in the whole idea of making topic clustering, because it's not just categorizing all these things, but also the first process of how you're going to take that data and how that will impact your infrastructure and potential costs along the way. So I find this very interesting because several of the previous speakers already spoke about search engines and the power of big data and so on. And I think that this definitely relates to that. So to expand on our data set, having in mind that we're going to face these problems, we decided to use an online data set that was taken from Kaggle, and also custom picked documents from different sources. The total number of sources is 30 plus. And all of them are covering different topics. It's important to say that all of them were in English, and there were also some blank documents so that we can see what will be the outcome of the clustering optimization. Here are the steps that are involved. So first of all, we define the corpus of documents, like I said, describe the data set. The second process is analysis and data pre-processing, which involves tokenization. We removed stop words. We also removed HTML tags and CSS and JavaScript. We also removed certain numbers because they gave us certain informative value and so on. In the third phase, we worked with pre-trained board embeddings. For starters, it was okay, even though board embeddings are not good if you want to work with specific topics, and it's better to work on your side creating, and just creating a matrix which is consistent with the values that are representing the similarity, performing the hierarchical clustering, and finally results. So in this case, it's important to note that there are two very different important concepts. The first concept is finding similarity between And even though on a dot level, we believe that based on the research that we make and also the experience that word similarity is very important in the process. So we decided to the typical fundamental word-to-vector approach, so that everyone who are going to start in this field, having in mind this is not about area that is valid of research and academia, it's a good place to start. So we use word-to-vec and word movers distance in order to find the semantic similarity between documents. The general idea, of course, is to transform linguistics and content into vector spaces that has precise mathematical features, so that we can use certain operations in order to make calculations between the embeddings, the vectors for the words and the documents that we have in the process. The key metrics that we use in the process are cosine similarity on the left and silhouette coefficient, which measures the medium intercluster distance and the minimal distance from the sample to every cluster in the process, in order to evaluate the quality of the clusters that we obtained in the end. And this is our final result. This is how the dendrogram looks for the hierarchical clustering problems. You can see that in certain cases, we have multiple documents that are completely alone in their own group, but in other cases, we have multiple documents that are clustered together. What we found is very interesting outcome is that the articles that belong to politics, marketing, and psychology actually were clustered in the same group. And at first we thought that it's not a good, that we did not use there, until of course we came to the part where we dig deeper into the data to see what was the problem. And we realized that all these documents of expressing and something like that that's not distinctive, and caused all this overlap of all these articles to belong in the same group, even though thematically seen and logically seen, they should belong in different topics. So idea how to address that is definitely we need to work. We can share this with you. Good starting point is to start building tools and giving the book Entity Oriented Research. Professor Christian Belloc, computer science professor and also former intern at Google. Here's how the content grouping might look like. So once you have all your content groups organized in a certain way, you know all these articles that are belonging in a certain groups, that figure them in Google Analytics. And then you can follow all these metrics on topic level. So when you see page views, when you see average time on the page and so on, you can see this on a topical level, not an individual level like it was before. Like I said, there are definitely advanced approaches that can be used for finding topical and document similarity, like using this embeddings and models. I'd like to emphasize once more that certain types of challenges in the SEO world that do take into consideration the word similarity problem. So that is why we started with word-to-vec first. So we'll stay in the game in the long run. Who will be the weakest link? Highly depends on how ready are we to admit that our positioning are going to be, our professions are going to be very, very hybrid. And ultimately it's true that the future here is not just equally distributed. In any case, we live in a very interesting time, and I think that it's our responsibility that no matter the fact that we don't know for sure what the future holds, we should always try to deliver innovative approaches that will help us prepare for what's next. Thank you for your attention. Do you have any questions?
Thank you very much for your talk. Do you have any question?
I have a question here.
Okay.
Okay. I have one question here from the explanation. There's something I want to ask here. What about the semantic similarity? Yeah, for the optimize the searching. It's work already or what in your research?
So to restate the question, if I understand correctly, you're asking about what was the exact approach for finding semantic similarity, correct?
Semantic, yeah, semantic similarity.
Uh,
For the meaning of the keyword or what?
We use the concept of VROOM3 to find the similarities between words in the first phase. So the idea is to create a normalized bag of words model for the content in the first place, and then try to present, of course, this all these words as vectors, and then find the similarity between these vectors in the vector space.
So it's already optimized.
That's for the words part. For the document part, you also need to combine this with the word mover distance approach.
Okay, thank you. Okay, thank you for the answer.
Thank you for the question.
Another question? No question? Thanks again for your talk.
Thank you.
Thank you very much, all of you, for your participation to this
Yeah,
session.
Emir.
Yeah.
It's my turn, I guess. I am in this room.
You are? Sorry.
My turn to present my work.
So your name.
Mohammed Girwi.
Your name does not appear in the program of this session.
But if you let me share my screen and can.
Mohammed.
Yes. Did you see my name?
Here, yes, but in the program I received from the chairperson and from the page of the conference, your name does not appear in the program, but it's okay then. If you want, you can present and we can listen to you. Okay.
Did you see my screen, sir?
Now, yes.
Hello, everyone. My name is Mohammed Girwi from the University of Galma from Algeria. Today we present our presentation entitled CPU feed amended U-shaped monopod ultra-wideband antenna for surface penetrating application. Presented by me, Mohammed Girwi, and the co-authors Abd Halim Shaban and Hassan Mbalek. Outline of our presentation. We start with introduction, then antenna design and geometry, results and discussion, and finally conclusion. Introduction. With the rapid advancement in wireless communication, ultra-wide technology have gained wide appreciation from scientists and engineers due to their wide bandwidth extending from 3.1 gigahertz to 10.6 gigahertz and lower consumption power. As can we see in this figure, comparison between ultra-wideband spectrum and emitted signal power with different standards like GSM, GPS, and Bluetooth. Ultra-wideband covers numerous narrowband wireless communication system, and it's also useful for other systems such as surface penetrating system. Surface penetrating is one of the main applications of ultra-wideband technology, which is largely employed in military civilian domains, such as disclosure of trapped people under virus type of antenna has been integrated within this surface system, such as bow-tie antenna, Tim horn antenna, tapered slot antenna, and Vivaldi antenna, and MIMO antenna. Unfortunately, most of these antenna have convoluted structure or big size. Our objective is to design small and easy to construct surface penetrating antenna are needed for this future SP system. To perform and analyze the results by simulating using computer simulation technology software CST, to analyze performance of the design antenna and fabricate the structure of the antenna. This is our antenna, the geometry of our antenna. The antenna is designed using the low-cost FR-cut epoxy substrate with the overall size 32 multiply 30.65 multiply 1.7 millimeter power 3 cube. And in this table, where we summarize all the parameters of our antenna. Results and discussion. Here we see evolution of the proposed antenna. We start with the conventional rectangular with the partial ground plane. As can you see, the antenna one doesn't cover the ultra wideband antenna. In the second step, we change the radiating patch from the rectangular to the decagon shape. We obtained large bandwidth, and in the last design, we set a cut and notched in the patch and in the ground plane. First, to reduce losses on the conductor, and to minimize the encumberment of the design of the antenna. Here we see in this figure the simulated and the measured VSWR are in good agreement, which cover in simulation. We covered large bandwidth that start from 3.005 to more than 11 gigahertz, and the measured results between cut 0.02 and 10.7 gigahertz. Little disagreement due to the fabrication tolerance and measurement curve. The radiation pattern of the proposed antenna in horizontal plane, excellent omnidirectional, and in E plane, bidirectional. Here, the gain and radiation efficiency of the proposed antenna, the gain varying between 0.5 and 3.5, and radiation efficiency is average more than 70%. Conclusion: a novel antenna for ultra-wideband operation has been presented in this work. The results show that the antenna would be an effective candidate for surface penetrant application. Thank you.
Thank you very much for your presentation.
Thank you.
Any question you have? No question? Thanks again for your talk.
Thank you. Thank you very much.
Mohammed,
Yes.
Dr. Mohammed.
Yes.
I just checked your name appears in section 6.2 yesterday, like here, but it's okay. It's not problem. Okay.
I sent email to reply.
No, it's not. It's not problem. Okay, no problem.
I changed, I changed my date to 12 to 13. I sent me.
Okay, it's not problem. Okay, so you're giving your presentations. Okay, thank you very much, all participations.
Thank you.
Wishing to meet in another international conference again. So I am ending this session now.